We can modify this model that we've developed on a square region to include a transient effect where the stream starts out at head equals 0, at time equals 0, but then at time greater than 0 the head is set at 1. This increase in head causes a pressure wave to propagate from this stream out in this direction. And so this is going to be our first example of a transient model. Here's the model that was set up to represent this case. And the geometry is the same geometry that we've used. The model or the materials will not be used for this simulation, and the Darcy's law is the physics. So if we expand that, all of these settings are the same. The hydraulic head boundary condition that we used last time, constant head on the upper boundary, head of 0, that's the same. But in this case, the head on the bottom is set to 1. Now here, our initial values are meaningful. They include or they specify that the pressure is 0 everywhere. In order to run a transient model, we also have to include a storage model. So if we take a look at this, this allows us to specify the properties that are required to generate a transient simulation. So we have the density of the fluid, the hydraulic conductivity that we used last time, but the storativity is also required here. This is actually the specific storage in units of 1 over pascals. So we use that value. And again, a default mesh. The study in this case is transient, and we'll select an appropriate time step and duration for the model. We run it again by selecting the equal sign here, clicking on that. And when we do that, we get this green bar moving across, and the simulation goes to this default display when it's finished. So this is what it looks like. We now have a high hydraulic head along the bottom boundary and a lower one up here on the top boundary. One of the new things about this solution is that it's transient, so we have a time associated with it. We expand this. We see that the time that's being plotted is from the parent, which is this selection right here gives us the parent. So we have the time at 1.57 e to the 7th. And you can see here we have a variety of times to pick from. So we take an early time. We see that this is just the beginning of the pressure wave starting to propagate along, and we get a somewhat later time, and it propagates further, and so forth. So if we go to our 1D plot, this is also along a section that is defined by a data set. You can see where that cut line is. So we have a cross-section that's along this line if we use cut line 2D. So we select this, and we see that this graph is indeed along cut line 2D. It's hydraulic head, and here are the profiles. This is the hydraulic head at early time, and then as time increases we have the head changing as so forth, like this, and eventually the head goes to a steady condition of just a linear a constant head gradient from this boundary to that boundary. One of the things we also can do with this is to generate a video output. So we select player, and if we press the this entry, we generate the player, and this is set up like a tape deck, so if we press that button, we'll play the transient response. You can see the pressure wave moving from bottom to top.